Hello everyone, welcome back to Math with Zanger. Let's continue on question 5, where no calculator is allowed. Given a graph of the curve C, which is 4x squared plus 3y squared plus 6y equal to 9. Part A is asking show that dy over dx equal to negative 4x over 3 times y plus 1. So what we're going to do is to derive the given equation 4x squared plus 3y squared plus 6y equal to 9. Since we saw there's both x and y, so we use implicit differentiation. You can try to differentiate at the same time and check the answer. Equal to ax plus 6y times dy dx plus 6 times dy dx equal to 0. 8x plus 6y plus 6 dy dx equal to 0. We shift everything to the right side and gives dy dx equal to negative 8x over 6y plus 6 equal to negative 4x over 3 times y plus 1. And that's the slope that we want to show. Part B. Using the information from Part A, find the second derivative in terms of x and y. Since we notice that the first derivative is in form of friction, so we use the quotient rule. And let's derive it. 3y plus 3 times negative 4 minus negative 4x times 3 dy dx over 3y plus 3 squared. Substitute dy dx into the equation, and that gives negative 12 times y plus 1 plus 12x times negative 4x over 3 y plus 1 over 3y plus 3 squared. To simplify, we can times y plus 1 on both denominator and numerator, and that gives negative 12y plus 1 squared minus 16x squared over 9 times y plus 1 cubed. And that's the first half of question 5, where only involve calculus A-B's knowledge, and the second half will involve calculus BC knowledge. Part C. In polar coordinates, the curve C is given by r equal to 3 over 2 plus sine theta for 0 to 2 pi. Find dr d theta. As theta increases, on what interval is the distance between the origin and the point r theta increasing? Let's first find dr d theta. R equal to 3 times 2 plus sine theta to the power of negative 1. Dr d theta equal to negative 3 times 2 plus sine theta to the power of negative 2 times cos theta. And that equals to negative 3 cos theta over 2 plus sine theta to the power of 2. Second, we want to find the interval where point r theta is increasing. And that point increasing when dr d theta is bigger than 0. It's a square in the denominator, so it would be always positive. So we only need to consider the numerator. Negative 3 cos theta has to be positive. Then cos theta has to be negative. In the cast diagram, cosine is positive in quadrant 4 and 1 and negative in quadrant 2 and 3. So the intervals that point increasing is at pi over 2 to 3 pi over 2. Question D. Find the area of S. S is the area inside of curve C, but outside of curve R equal to 2. Let's first find the intersection. 3 over 2 plus sine theta equal to 2. 3 equal to 4 plus 2 sine theta. 2 sine theta equal to negative 1. Sine theta equal to negative 1 over 2. In the interval of 0 to 2 pi, theta is equal to 7 pi over 6 and 11 pi over 6. That sine theta is equal to negative 1 over 2. To find the area between polar curves is 1 over 2 integral a to b big R squared minus small r squared d theta. And we can plug everything in. That gives a equal to 1 over 2 integral 7 pi over 6 to 11 pi over 6. 3 over 2 plus sine theta squared minus 2 squared d theta. And the final interval expression is like this. Area of S. And that's everything for FRQ question 5.